the recording. Okay, this is the famous differences of the square. The differences of cubic. The formula is a minus b, parenthesis, a squared plus ab plus b squared. And the sum of the cubic is similar formula, but it's plus, and it's minus in the middle of the trinomial. Well, you know, the sum of the square, impossible to do anything. This is prime expression. Okay, the problem number 8 is typical. It's typical difference of a square. How do you know? Well, number 1 is binomial. Number 2, the number involved in this problem is 16 and 81, and both are perfect square numbers. I know very well the square root of 16 is 4, and the square root of 81 is 9. By the way, the exponent also is even. 2, 4, 6 is classical. So now when you introduce here x squared inside, you have x. And this is working like a and b in my formula. What formula? That formula. This is the factorization. As you open two parentheses, you put 4x is a, and b is 9. Plus or minus, or negative, plus, doesn't matter. The order is not important, plus, minus. Okay, the answer is 4x plus 9 times 4x minus 9. Any question? No? Okay. Doing number 9. Number 9 is a little bit tricky. Look, number 9 is 50 minus a squared. You say, wow, professor. 50 is no perfect square number, and 8 is no perfect square number. Entonces, it's no different of a square. Yes, it's different of a square, but the first thing, remember, I repeat 1,000 times, you should do is find the GCF. Well, when the GCF is 1, well, to say I don't need to do anything. But when the GCF is no 1, you say, what is the GCF between 50 and 8? I have no idea. I take 50, I take 8, break it down, primary factorization, divided by 225, divided by 55. This is the factorization 50. And the factorization is 2422. So what is the GCF? Well, the only factor is common between 50 and a is 2. You factor out 2. Okay, when you factor out 2 in our expression, look at that. Factor out 2 in our expression, open parenthesis, stay inside the parenthesis 25. Because remember, the thing I am doing is factor out 2 and stay 25. Minus, when you factor out that 2, stay 4. It's 4a squared. Wow, and now 25 and 4 both are perfect square. 25 is 5. Square root 4a squared is 2a. And it's working like a A and B in our formula, no? It's again differences of the square. Please don't forget the extra 2 that was the result of the GCF. Like when you bring down that 2 and you open now 2 parentheses and you put 5, que es A in the formula, 2A in the formula, que es B, and plus or minus. Boom. End the story. This was interesting because this example was a combination. GCF first, don't forget please. And after the GCF, factorization, binomial, exactly different of squares. Good. Okay, entonces now in the real life, we combine different technique, no? Remember the strategy. The strategy is, number one, investigate if we have or no GCF. Si the answer is yes, well, entonces you factor out. Si the answer is no, well, keep going. Keep going. How many turns? 4 grouping. Entonces now, wait, I forgot to copy. Okay, don't worry. The answer of this was 2, 5 plus 2a, paréntesis, 5 minus 2a. Okay, super. Okay, let's do it. Go back. Okay. Now let's move on to the number 10. Number 10, I suppose que es easier. Because number 10 is 16C4 minus D4, no? This is classical difference of a square. Not only when the exponent is 2, but the exponent in general is even 2, 4, 6. Now square root this guy is 4C squared. And square root this guy is D squared. Entonces you open two parentheses. You put 4C squared, 4C squared, D squared, D squared plus or minus. And that's it. No. Why no? Because I can see here, another difference of a square. This is sum of a square. I know that sum of a square is non-factorable expression. Entonces, pero the difference of a square, yes, is factorable equation, expression, sorry. Therefore, I need to continue, factor completed. Entonces, square root 4C squared es 2C. And square root D squared es D. Okay, entonces the last step of the factorization is, look at that. Okay, you copy the sum of the square. It's impossible to break it down. However, this, yes, and 2, new. Okay, 2C, 2C, DD plus or minus. Okay, our factorization is too long, contain 3 factors. Okay, let me copy. I don't see we have a space for the copy that. No, we have, well, yeah, we try. Parentheses, 4C squared plus D squared, 2C plus D, and 2C minus D. So I suppose that you understand very well. Okay, you keep going the factorization when it's possible. And see you detecting how we have another difference of a square. It's obviously you cannot stop. You need to continue the factorization because it's factor complete. You know, it's similar. See you, for example, you factorization 8, and you see 2 and 4, and you stop. No. Why no? Because 2 is prime, but 4 no. So you keep going. Break it down to 1, 2. It's important to understand que the command, the problem, the objective, the goal in this problem is factor completed. And you cannot stop if is there one possibility to continue. Okay, 11 is easy. Wow, 11 is the sum of cubic. Look at that. 11 is 3x is cube square, no? It's a square of a cubic. No, it's square. Sorry. Entonces, no. Plus 27. I know that the sum of a square is not factorable, but in this case, you need to try if it's possible to find GCF. GCF is obviously 3. Because 3 plus 27 is 3 and 9, 3 and 3. 27 is formed by 3 factors. And 3 is prime number is only 1. Entonces, at least share one factor, que es 3. Entonces, now you factor out 3 and stay x squared plus 9. Wow, I like factorization this, but it's impossible because I know that the sum of the square is no, it's prime. Okay, remember this formula. A squared plus b squared is prime, therefore we cannot do anything. And this is my final answer. Okay, you copy now. 3 x squared plus 9. Well, I did something. I did GCF at least. And GCF has one technique. It's some students underestimate. And in my opinion, it's the most important. It's the first thing you should do. Okay? Okay? Okay. Let's move on to the next page. That's page number 3. Then we practice. Let me erase everything. Okay, let me try to upload this document. Oh, I don't remember very well. Practice 3. No, this is not practice 3. Practice 3. Review. This guy. I suppose. Yes. Okay, what page? That page. Let me see. What page? That page. Okay, boom. Okay, we continue. Binomial again. Factor binomial. In this case, factor a sum or difference of cubic. Okay, easy. Let's practice. Suppose 12. In 12 we have 8x cubic minus 27. The thing that we are doing is find the cubic root of this expression. This is 3, not 2. It's so big as 2x. And the cubic root 27 is so big as 3. And it's working like a and b in my formula. Entonces, let me recall the formula. The formula says a minus b, a squared plus ab plus b squared. In our specific example, a is 2x. Look. And b is 3. Now a squared is 2x squared, therefore x squared plus multiplication a and b, multiplication a and b in our specific example is 3 times 2 is 6x plus a squared the second get b get 3 squared 9. Done. Finals. Typical factorization, wow, of a difference of cubic. Difference of cubic. Okay, let me copy. Is parenthesis 2x minus 3, 4x squared plus 6, x plus 9. Super. Everyone follow me? Okay. Move on to number 13. 13 is a to the 6th power plus 125. Again, it's a sum of cubic. Remember, any exponent multiple of 3, like a 3, like a 6, like a 9, like a 12, is considered like a cubic, no? Entonces you find the cubic root of a to the 6th power, que es a squared. How do you know? 6 divided by 3 is 2, no? And cubic root 125 is 5. Okay, entonces this is my a and this is my b and the formula. What is the formula? The formula is a plus b times a squared minus ab plus b squared. This is the formula for the factorization. A is a squared, it's a coincidence, but it's squared, plus 5 get b in our specific example. And the trinomial part, we have a squared is a to the 4th power. Minus multiplication both get 5a squared plus the square root of 5 get 25. Okay, so we have a squared plus 5, a 4 power minus 5, a squared plus 25. Super good. Okay, 13. Binomial is super easy, in my opinion. Trinomial is complicated, but a binomial no. It's easy, it's just a formula. That's it. Let's move on 14. 14 is also binomial. It's 24 x to the 4th power minus 3x y cubic. Okay, remember as always, GCF. Well, GCF between the numerical part is 24 and 3 is obvious 3. And the variable part, you have x to the 4th power and you have x to the 1. You take always the smallest part. And why not? Why is not common? Because the first term we have no y and the second yes, but there's no common. Really common. Common is repetition. Same. Repeat, share. Then you factor out 3x. When you factor out 3x, it's the 8 is 8 is 8 x to the 3rd power minus 3 go out, x go out, y cubic. Woo! And this is classical, this expression is classical difference of cubic. So now I found cubic root ax cubic is 2x. And find cubic root y cubic is just y, and it's working in my formula like a and b. And the formula is, let me go with the formula here. The formula of the a is cubic minus b cubic is a minus b, a squared plus ab plus b squared. In our specific example, a is 2x. We discovered that. And b is what? Okay. 6 is in our specific. Okay. Don't forget, this is important. The organization of mathematics is extremely important. Look, don't forget this 3x was the GCF and the first step. I just copy. And this don't participate in the game. Participate in the final answer, but not in the game. So this is a x cubic minus y cubic. And the factorization is open to, bueno, ya copy 3x again, pero ya copy to parentheses, que es the parenthesis of the formula. And a is 2x. And b is y. And minus, look at that. Square first is 4x squared plus multiplication both is 2xy in alphabetic order plus square the second is y squared. Boom, final answer. In this case, this factorization was the combination GCS first and after the difference of cubic. Is 3x, let me copy the 3x, that was the expression for the GCF, 2x minus y, 4x squared plus 2xy plus y squared. Something like that. Okay, not bad. How do you feel? Okay, let me check in the opinion and let me check in the attendance again. Okay, wow, today not too much student. Edward, Dalida, Angelica, as always, Jimenez, Christopher Espinosa, good for you. Kevin is coming early, as always. Noel, okay, Dalida, I know that you are here. Okay, and the rest is coming early. Juan, Kendry, David,
Yeah.
Santana, Alex Manuel, and Jasmine. Okay. Good. Okay. 15 now. 15 look like hard or horrible, but it's no big deal. Okay, the reason is it's a fraction, but I don't care the fraction. K to the what point? I don't see it. To the fifth power. To the fifth power. Okay, to the fifth power. Wow. It's a 5. To the fifth power. Plus 1 over 8 k squared. It's obvious that the first thing you should do is GCF. GCF is k squared. Remember, when the variable is easy because you take the smaller exponent. Okay, same in between 5 and 2, the smaller is 2. And you factor out 2. It's take k cubic because 3 plus 2 is 5 plus 1 over 8. Y I suppose that that part is the sum of cubic. And the cubic root of k cubic is just k. And the cubic root 1 over 8. Well, this is considered like a cubic root 1 over cubic root 8. And cubic root 1 is always 1. Any root, any power. The 1 is a magic number. And this is 2, 1/2. And this is like my formula like A, and this is my formula like a B. The factorization we continue after the GCF, open to parentheses. It's a k squared. Binomial, trinomial. Inside the binomial, I put k plus 1/2. Okay, it's A and B. Look at that. Entonces inside the trinomial you have a squared, que es k squared in our case, minus, it's minus here. Multiplication both. Multiplication is 1/2 times k is 1/2 k. Doesn't matter, like that, it's good. Plus 1/2 squared is 1 over 4. The 1/2 squared is 1 squared divided by 2 squared. 1 squared is 1, 2 squared is 4. Boom, it's 1 4. And this is the final answer of the factorization. 15 is k squared, k plus 1/2, k squared minus 1/2 k plus 1/4, 1 over 4. Okay, that was no big deal. Let me erase this 3. Now, okay, let's move on to 16. 16 look like weird because 16. Let me explain in detail this. Pay attention, please. 9x squared minus 12x plus 4. And the first thing you say, wow, professor, this is a special trinomial because the coefficients in front the x squared 9, no 1. So I'm doing the multiplication, this and this, 36 something. No, you can. But this is complicated. However, you expend 2 seconds to verification. Okay, this trinomial is also perfect square. How you verification? Well, the first clue is 9 and 4 both are perfect square number. So maybe yes, maybe no. The entire trinomial is perfect square. And the test to prove that it's perfect square, you find the square root 9x squared, okay, 3x. You find the square root this guy, que is square root 4 is 2. And you multiplication both times extra 2. 3x times 2 times extra. This is the extra guy. And you get 12 is exactly the same of this middle term. So now, when this situation happens, I say, wow, this is a perfect square trinomial. Perfect square trinomial. And the factorization is super easy because I know that the perfect square trinomial have only one trinomial, not two. Okay, no necessary open two parentheses. No, why no? Because they are twin brothers. If they are twin brothers, so you open only one, you put a square, and inside you put 3x and 2. Okay, it's this guy and this guy. And what sign in the middle? Minus. Why minus? Because this sign is minus. Because I know that this sign always in perfect square trinomial is positive. End the story. And the answer is 3x minus 2 square. Ajá, entonces, ok. Entonces yo digo, bueno, profesor, suppose que I do not realize que es perfect square. We can do that by the special trinomial. Of course you can, but it's too long and complicated. The easy way, in my opinion, is so you spend. So one clue is, well, okay. The number involved in the problem is perfect square. For example, 17 is similar. It's 25x squared plus 20xy plus 4y squared. So now you say, wow, look at this. You consider it as special, 25 and 4 is 100. Wow, 100 is too long, too big number. No. I never do it that way. However, no, see, I need to do. But no, I try to avoid. How? Verification. 25 and 4 is perfect square number. Nice. And square root 25, x squared is 5x. And square root 4 is 2. And you multiply 5x times 2 times extra 2 is 20. 20, wait. This I forgot here. Y squared is y. Entonces es y here. Y. Entonces xy. Exactly the same of this. Look. So now I discover this trinomial is perfect square trinomial. And the factorization have only one parenthesis. Square. They are twin brothers. That's 5x, 2y, and plus. Because this sign is plus. End the story. Super easy. This is a powerful tool. Can help me to solving a complicated thing. In this case, see, I try to do using a special trinomial. You multiply here as 100. Entonces now I make a decision to try using try and error. And try and error, you know, horrible is 5x times 5x. Maybe 5x, okay? And maybe here 2y, and this combination work. It's no big deal. So it's important that you are familiar with any method and you try to discover the easy way in each case. No, always the same thing. No. Let's move on to the next page. Get the page number 4. Okay, no, I erase everything. In the page number 4, I see here over page number 4. I suppose it's this. Yes. Okay, page number 4. Let me see. It's 18 something. I suppose it's this page. Boom. Okay, we continue working with the factor polynomial completed. Okay, completed. So you categorize binomial, trinomial, grouping, bam. 18 is 2m squared minus 18. Oh, I saw okay, we have GCF is 2. It's obvious, right? And you factor out 1, 2 outside and stay alive m squared minus 9, no? And stop, no, keep going because I discover okay, that expression is a difference of a square, and thus I need to apply the difference of a square formula. Is is 2, to open two parentheses, and inside the parentheses you put the square root. This is M33 plus or minus, done, final answer. Okay, one more time we apply GCF first and difference of square secondly. The answer is 2 times M plus 3 A minus 3. Okay. 19. Now, this is like a miscellaneous problem. It's 10y squared plus 3y plus 4. Wow, this is special, no? Not regular, because it's 10, the coefficient is 10. And 10, bueno, 4 is perfect square, pero 10 no. Entonces it's impossible to be perfect square. No perfect square trinomial. This is impossible, because 10 is no perfect square. And GCF, no, we have no GCF. So, unfortunately, I need to do using special. And multiplication that, 40. I try to find the key open the door. The key open the door to factor of 40, somehow addition or subtraction give me 3. I suppose it's A and 5. Because 8 times 5 is 40, 8 minus 5 is 3. We have another combination. Oh no. Let me try to investigate another combination. Because I suppose A and 5 is... Okay, what is the reason I don't like this combination? Because a subtraction, A minus 5. I don't see any negative number in my trinomial. Because this, in my opinion, smells no good. Okay. Let me check it out, see if we have another combination or not. Okay. No, there are no. Look at 40, look. 40 is 40 times 1. 40, sorry, is 20 times 2. Now remember, you adding and subtracting. 22, 18. My goal is 8, is 3. 40 is divided by 3, no. Divided by 4, yes, it's 10 and 4. When you're adding 14, when you're subtracting is 6. We are close, but don't touch. We continue 40 by 5, yes, it's 8 and 5. When you're adding a 13, when you're subtracting is 3. I believe that this is the combination. By 6, no. By 7, no. By 8, we have repetition. So that when that repetition is because it's cyclical. And I finish. Okay, I try to do my best. So I bring down 10y squared. I put 8y minus 5y, no? Because a minus 5 is 3. I need to write one equivalent expression than the original, no? Okay, now this is a crucial moment to apply grouping. Factorization the red couple, factorization the blue couple. And the GCF in the first couple is obvious, is 2y. We have 5y plus 4. And the GCF in that part, I have no idea. Maybe it's 1 or negative 1. Suppose que I factor out negative 1. We have 5y, but now it's minus 4. Let me check the sign, see I did well or not. Negative and negative positive, negative and positive negative. Okay. So unfortunately, you can see, wow, this binomial and this binomial is not the same. That means this combination doesn't work. And we have no more combination here. So what is the answer, Professor? Oh, the answer is prime. This trinomial is impossible to do the factors. I tried to do my best, but it was impossible. And sometimes happen. Not frequently, but it happen. Okay? I promise in the test, no. I don't put any prime because I want to see how you are doing the factorization. But do you understand the idea? Do you understand? We try any combination. We discover one combination, potential combination, can maybe work. However, this potential combination doesn't work. How do you know it doesn't work? Because when you are doing the part, the stage of the grouping, we never get the same binomial, and it's a contradiction. Okay. We don't finish that packet, I suppose, but I don't care because you continue working. No. You focus in the homework and focus in the test. It's the important thing. This review is too long. Okay, if you want to practice, you can. You have time. Basically, Monday we start new chapter. Okay, by the way, yeah, it's easy. Okay, chapter 4 and chapter 5 is super easy. We are doing the test in only 1 week, and that's it. We finished the course. Remember, the course is over October 15, so we have only 2 weeks to finish. And the final is mandatory. Okay, the final is mandatory, and the final is community. Everything together. But don't worry, everything gonna be okay. I am so proud with you. This is fantastic class. Okay, I never have in my life class like you. Normally, the student that take this class is a mess. And you are good student. Okay, let me do it one more, and that's it. 20, 20, and 20. We have 20. 20 and 20. We have 48 y cubic plus 81. Well, I have no idea. I suppose que es binomial. This pone 3, entonces I suppose que es cubic. Pero 48 and 81 is no perfect cubic number. So you try to find the cubic root 48 and the cubic root 81. Give me, if you put in the calculator, maybe give me a decimal. Entonces, I don't understand anything. Well, I understand. See, I follow in the procedure. GCF is the first thing. GCF between 48 and 81. Let me try. The systematic way to do that, you take both number and you are doing the primary factorization. Divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So my systematic way is divided by 2, divided by 2, divided by 2. When it's impossible divided by 2, you start in the sequence of the primary number 2, 3, 5, 7, 11, and so on. Entonces now you divide by 81. No, it's not even because ending in 1. Entonces, to be even, the number ending in, so the last digit is even number. 0. 81, no, divided by 3 is 27. Divided by 3 is 9. And divided by 3 is 3. Entonces, what is the common factor que share 48 and 81 is 3. It's 3. 3 is the GCF. And I factor out 3. I put 3 out. So we have, look. So you factor out 3, stay alive in that number. Let me use another 5, 2, 2, 2, and 2. And 4, 2 is 16. Is 16? Is 16? Is 16? 16 what? 16 y cubic plus. So you factor out 3, stay 1, 2, 3. Wait. is, yeah, 48, yeah. 48 is 16 times 3, yeah. It's 27, no? It's 27. And this look like sum of cubic. However, no, because 16 is not perfect cube. It's a cubic root. 16 y squared, it's decimal. And decimal is not good in the factorization. 27, yes, pero 16 no. Que es 3. Entonces, I believe que the best option is que you leave it like that. Only GCF and that's it. Only GCF and that's it. Okay, so the answer is 3. 16y cubic plus 27. So let me clarify something. Okay. I come back to the main screen. Stop sharing any screen. Do you see my face? Okay, listen to me. Today I am sending the test number 3. This test is due next Wednesday, que es September 29. Clear? And also do the test number 3 in Alex online. Correct? Now, today we finish this chapter. Monday we start new chapter, que es the chapter 4. Okay? Que es short. We finish in 1 week. And we have another week, the last week with the chapter 5, including final test. It's clear? Okay. Now, guys, have a nice day. Okay, I'm leaving. Waiting for my second video of the YouTube video. The second link, second email, sorry, for the YouTube video. Thank you.